Hi, myself Devananda Rao, working as Associate Professor in the Department of CSE, MLR Institute of Technology, Hyderabad. Today's topic is type checking, and also we are going to discuss the types of type checking and distinguish between static and dynamic type checking. A compiler must check the source program follows both syntactic and semantic conventions of the source language. So, syntactic and semantic constructs will be checked by the compiler. Then types of the type checking. There are two types: static type checking, dynamic type checking. Static type checking, dynamic type checking. What is static type checking? Static type checking is defined as a type checking performed at compile time. It checks the type variables at compile time, which means the type of the variable is known at the compile time. During compilation only the type of variable is verified. Examples of type check. First one is type check. A compiler should report an error if an operator is applied to an incompatible operand. So, operator is applied to incompatible operand. For example, number is a integer variable assigned a value 5 and character is a variable of type character assigned a value a. These are the two variables, integer variable and character variable. If you trying to add these two values, that is integer, that is result is equals to num plus character. Num plus character. Num is an integer type, character is a character type. If you trying to add these two operands with operator plus, it will produce compilation error. That is incompatible type. Incompatible type. Incompatible type. This is type checks done at compile time. This is static type check. Second one is the flow of control checks. The flow of control checks, the statements that ensure that causes the flow of control to leave a construct must have some place to which to transfer the flow of control. Suppose if you take if you want to use break, you have to use break statement within the loop. If you use break outside the loop, it will produce the error. For example, integer I is equals to 0 while I less than 5 having some code, then I plus plus followed by break. Here break is a statement defined outside the while loop, so that it will produce the compilation error, that is break outside of the loop. Break outside of the loop. This is flow of control check. This is done by the compiler during compilation. Then uniqueness check. There are situations in which an object must be defined only once. You should not declare variable more than once. For example, here in Pascal the declaration will be variable x is integer semicolon x is real. This will produce error, compilation error, that is already x is defined as integer. Now second time x is declared as real. This is x is already declared, so that this is compilation error. Identifier x is defined earlier, that is compilation error. So uniqueness check, only one time you have to declare the same variable. Next, name related check. Sometimes the same name may appear two or more times. For example, in ADA, a loop may have name that appears at the beginning and the end of the construct. In ADA language, the loops will begin with the loop name, with the beginning same name and end with the same name. The compiler must check that the same name is used at both places. Next, dynamic type checks. Dynamic type checking is defined as the type checking being done at runtime. During execution, type checking is done. In dynamic checking, types are associated with values, not at variables. For example, X in Python, X is equals to 5, X is an integer, X is hello. Now X is a string. Now X is a string. Initially X is defined as integer. Now X is string. So here Python allows this type of declarations. This is dynamic checking. Next, the distinguish between static and dynamic checking. Static checking, the type checking done at compile time. Dynamic checking, the check is during runtime, during execution time. Then properties can be verified before run. Anything should be verified before execution, before run. Permits the programmer to be less concerned with the types, less concerned with these types. Then static checking can catch many common errors in static type checking. Then dynamic checking is mandatory in some situations such as array bound check. What is array bound check? For example, integer a is a array of 1000 and integer I is equals to 1010. Now if you want to assign a of I is equals to 42, this may lead to some irregularities, some unpredictable behavior. Integer a is a of array a is array of 1000 locations, integers. Then I is a address 1010, a of I is equals to 42. If you like do this is example of array bounds. For these situations, dynamic checking is required. Then desirable when faster execution is important. So static checking is faster than dynamic checking, but dynamic checking is more robust and clear code. And the another is the position of the type checker in the compiler. We have many phases in the 6 phases in the compiler, starting with the lexical analyzer and so on. Then where the type checker is placed. Second phase is syntax analyzer, or also called as parser. Parser takes a sequence of tokens as input and produce syntax tree. Then here the type checker will place a crucial role. Will check the types. After checking types, it will produce the same syntax tree without any error, type mismatches. From this syntax tree, by using intermediate code generator, we can generate the intermediate code. Like that will continue. The token stream from the lexical analyzer are passed to the parser. The parser will generate a syntax tree. When a program is converted into syntax tree, the type checker plays a crucial role. The type checker will check if any modifications are present, then it will modify. It produces a syntax tree, and after that intermediate code generation is done. This is the position of the type checker in the compiler. Thank you.